Yeah, so we're a new consulting company. Got our start about last year, and what we've tried to do is get involved largely in the private cloud world. And that's largely what this talk is about. So we're going to talk a little bit about some of the industry trends. We're going to talk about some of the reasons that some of the things that people are talking about, some of the trends that we're being able to see, and we're talking about what the customers are currently trying to do. So trying to get our story so far. Where did we come from? Where did the industry get to right today? And when I was thinking about this, the question was, well, where should I start? So I'm going to start at the beginning. And the point of this story isn't so much that ENIAC was an enormous machine which required its own entire room in order to survive, but there's this constant trend. So we start with ENIAC, we move to computer rooms, to network closets, so we're always getting smaller, computers getting denser, and then we moved into actual data centers. From data centers, we actually get to cloud. This is a really big thing. Next slide we'll be talking about that. And then from cloud we get to the hyperscalers, from the hyperscalers to infrastructure as a service. And the punchline here is just that growth in computing power has been driven by the quest to find economies of scale and economies of scope in compute. We want denser, denser, denser. We want faster, faster, faster. We want cheaper, cheaper, cheaper. And so things have to get smaller, smaller, smaller. And this gets to the point where, so one way you can think about cloud is that it is the whole point of cloud is it's not just something that runs on someone else's server. It's the fact that in a sense you have pushed your personal compute down to zero because you no longer care about its care and feeding. You don't care about its network. You don't care about the actual physical server. That's now somebody else's problem. You're paying them for it, but then you get to use the resources itself. Brief history of cloud, right? So the virtualization is, from my perspective, because I'm old, it's a new technology because it got its start in 1999, only the last century. And then AWS introduced 2006, OpenStack in 2010, Kubernetes by 2014, and sort of our star as a service has been the latest trend over the last couple of years, where you basically just have some API-driven service. So once again, the punchline of this is that all these additional layers of abstraction have been built to hide the physical infrastructure. You are far, far, far away from it, and you keep on getting pushed farther and farther and farther away from it, such that from your compute paradigm is now that you're just stitching together these remote APIs in some generic workflow. There are even workflow engines to do this for you. So you don't have to know a single thing about IP headers. You don't have to know a single thing about what the machine is actually doing. You don't care about execution stack. You don't care about heap. All you care about is stitching these APIs together. You're very, very far abstracted from what's gone on over there. So the net conclusion of that is that there's no shortage of organizations which have either lost or never had this expertise in systems and networks and the low-level stuff. Because the whole trend of the industry has been to abstract and to move away from all this, especially for this past decade. And so we've had a large number of firms which are not just cloud native, but were cloud first. So they were born in the cloud, they grew up in the cloud, and they're still heavily in the cloud. And the idea that you would want to do something of yourself, you would never ever consider because, again, your abstraction layer is so high. So that lets me segue nicely into what I'm calling the performance wheel, but I've seen this talked about elsewhere. I'm sure that if for any of you who have been around the industry for any length of time are going to recognize this pattern, that every single shop seems to go through this, and that perpetually you are being asked by upper management to lower costs, improve your serving quality, and improve your performance. What does this mean? And you go call a consultant, the consultant comes in and says, you know what, you really need to do what you're best at and ruthlessly outsource everything else. And so you say, okay, I will outsource everything else, no problem. And so you do that, and sure enough, you really do get the cost savings. It really is cheaper to outsource than concentrate on what you're doing best. But then markets have habits of shifting, stuff moves on, all of a sudden new features are being required, and your old outsourcing company cannot keep up with this new rate of features that you are intending to push out. So your outsourcing becomes bloated and inefficient. The market shifts, which forces you to in-source because you're in search of lower cost, better quality, better performance, and you have this brand new need. I need to do something new. It needs to be cheaper, faster, better. And so you start to in-source because you can no longer do this outsource. Can we save questions to the end, sorry?
Yeah, can you speak a little closer to me?
Oh, I absolutely apologize for that. That is completely, totally my fault. Okay. All right, so I'll try this one, and hopefully this is a little awesome. My apologies about the other part, the earlier part. Anyway, messed up my performance wheel, because what I'm trying to talk about is the pattern is you outsource and then you insource, and then what happens is insourcing becomes bloated and inefficient, and so you have to outsource again, and you're in this wheel, and you're perpetually spinning and spinning and spinning around it. And every organization is at some point on this wheel. Yours, you can probably pinpoint exactly where it is. It will be different for everyone. So to take this back to cloud native companies have hit this exact same performance wheel that every other company and every other technology shop has ever had. And so what are they discovering problems with? One is cloud cost, especially as you get bigger and bigger and bigger. Cloud costs move up linearly. There are issues of control, and this is actually a really big one, and people are discovering, especially in this day and age when a lot of the people really interested in AI are particularly worried about data sovereignty. They need to control their data, they need to understand who has access to data, they need to prevent unapproved access to this data, and this becomes a super, super big deal, and we're going to see it become an even bigger deal over the next year as the lawsuits start coming out about copyright and who has access to what data to train your model on. There are issues with performance. Clouds can scale, they do really, really great, but then all of a sudden you're spending $1 million and you're wondering where it's all going. There are compliance issues. You get a lot of stuff that, depending upon where you are operating, there are geographical restrictions, there are privacy requirements, and you may have a provider that claims that they are compliant with it, but can you actually survive an audit when you go to do this? And the last thing I want to talk about here for where cloud native companies are discovering problems are largely with sizes of scope and sizing. And so part of it is, one of the original sales pitches of cloud is you would spin up additional instances as you need them, and you would take them back down when you don't. And it was a wonderful and beautiful idea. The number of shops that actually implemented are surprisingly small. And so this winds up being a big deal for a lot of the cloud native companies, because now all of a sudden you've spun up this large number of VMs, and then even when your traffic is low, you still have this large number of VMs because you never bought into the, well, I should just reduce these when I don't need them. I should reduce the number that I have and then spin them back up when I need them. So, cloud native means cloud dependent. This slide I kind of went back and forth on it, including because I have to talk a little bit about accounting, so my apologies for this. But when accountants are trying to do cost estimations, what is something going to cost me next year? Costs fall into one of two categories. It's either a fixed expense or else it's a variable expense, and that's it. And we can argue and go back and forth about what qualifies about which category, and if you need some entertainment with your accountant, I encourage you to do that. But the idea of a fixed cost is a cost you spend once. So if you buy a server, you buy the server once, you exchange money once. You now have the server, it is yours forever until you choose to get rid of it. But electricity is a variable cost. You choose how often you want that server to run. So if you have it run for 5 hours a day, you only need to pay for 5 hours of electricity. If you want it to run 24 hours a day, then you have to pay for 24 hours of electricity. But that cost is variable. It depends upon how much you use it. What's the point of this? So if you look at the cost versus number of VMs, how many VMs can I fit on top of a server? And when you are self-hosting, your cost curve is largely flat because you have to pay for the purchase of the equipment, and sure, if you run it 24 hours a day, fine, you have to pay the electricity for 24 hours a day, but this winds up being a fairly fixed number. Whereas if you go into a cloud provider and you want to spin up a new VM in a cloud provider, they just charge you per VM. So that means VMs themselves are now variable costs, not fixed costs. Remember, the server, fixed cost. VMs, variable costs. So the more VMs I have, the more expensive it gets. And then the fewer I have, the less it gets. The punchline of this slide is in that third part, the verses. Those lines cross. This is the key point when I'm talking about cost, is that at some magical point, and the exact number is going to vary depending upon the cost of your servers, depending upon the cost of your service, depending upon the competitive environment, and all these other cost factors, at some point you will be big enough that your lines will cross, it will be cheaper to self-host than it will be to go out to a cloud. This is called an economy of scale or an economy of scope. The bigger you are, the bigger this economy happens to get. And that's one of the cost reasons that people who are cloud native are looking back and saying, well, I hit a certain point, maybe I'm past that point, and in order to save costs, improve performance, improve quality, it might want to consider doing something myself as opposed to letting the cloud provider do it. There are also issues of control. One of the bad things happen to everyone. I'm not here to make fun of GCP, believe it or not. I'm actually not here to make fun of the public clouds. I think they're fantastic services, but they have their place, and I'm trying to establish the boundaries about that. So there are definitely control issues. Everyone's aware that GCP auto-deleted the entire account of a $125 billion pension fund. This was Australia's superannuation fund. Now, because it was a very well-run fund, they had proper disaster recovery and business continuity plans in place. So they had enough dissimilar redundancy that they didn't just have a backup provider waiting inside a GCP, because that was all their backup stuff inside a GCP was deleted when their GCP account was deleted, but they had it in another provider, so they were able to restore from backup and get back to work. Good for them. They planned well, they executed well, they did what they were supposed to do. But again, the punchline is, when you start thinking about this, being cloud native means being cloud dependent, which means that if the cloud screws up, they've screwed you up. So you can't blame yourself for that, you gotta blame them. So yes, you can try to bound this with SLAs, but you've discovered very quickly that SLAs are very company dependent, and they're dependent upon how well your negotiation skills are when you signed a contract with that particular provider. I've gone on about performance. This is a very technical crowd, so I'm not going to spend a lot of time on this, but yes, you can have VM contention, network contention, API access contention, data gravity, and I think I already mentioned data sovereignty, which is becoming a bigger and bigger and bigger deal. There's one that I left off of this particular slide, but I just had a customer bring this up literally just this last week, which is why I haven't updated my slide, because I'm lazy. But the idea isn't just data sovereignty, the idea is compute sovereignty, meaning if you're a fund in Dubai, Dubai is a tier 2 country. You are not allowed by US trade restrictions to buy more than some fixed amount of GPUs for your acceleration for your own clouds that you intend to build. So now you're in a bind. If all of a sudden compute sovereignty is a big deal, how can you outsource for this? How can you try to insource in that? You begin to see the bind that they're in, but the legacy models do not work for them for this particular instance. So this is brand new, which I just learned about this last week. I already talked briefly about some of the compliance issues. You need to make sure that your vendor is appropriately compliant. One of the ways to guarantee compliance is to do it yourself. And this way you can survive any audit, you can present to any auditor, you can go through appropriate steps, you know exactly what level of control that you have, and so you can guarantee the compliance that you need with what your compliance department says you need to do. We're getting towards the end of this. We also have an issue with sizing and scoping of service. I talked a little bit about this earlier, but what I really wanted to point out here is that if any of you have run a real-world production load, probably you've noticed it has some 24-hour periodicity to it. So there's a time of day when all your end users are up and about and are using your service, and then there's a time of day when they're asleep and they're not using your service. So you've got this nice sine wave of utilization out of it. One of the issues is that that's great for production loads, but in addition to production loads, you probably also have a staging environment, you have dev environments, you have a full CI/CD pipeline, and so you perpetually have a test environment that you are always executing unit tests and regression tests and the like against, which means that your actual observed load from the computer's perspective is more like the one in the bottom there. It's jagged. It's not smooth at all. It actually varies tremendously, and this is one of the things where if you know what your load looks like, if you know what your performance looks like, then when you start to do it yourself and you want to start scoping and scaling out to better control your costs, you want the nice load case that we see in the top of the picture, not the ugly case at the bottom. And so therefore you want to export this jagginess to a cloud provider, so they have to take the risk on that, while you maintain your production load yourself, because that is nice, easily predictable, and therefore easily costable. Now, there's some negative externalities, of course, to doing it yourself. There's a lot of other expenses, a lot of other risks. The problem is that you have risks no matter what it is that you do. And so what a lot of guys are winding up doing is they want to dip their toes in the water, and so they wind up with a hybrid model. And once you have a hybrid model, then all of a sudden you're concerned about networking, you're concerned about transferring data in and out between the clouds. Data gravity is real. Egress out of the clouds are very, very expensive. And so you have some level of negotiations to go through, and you have some clever networking decisions to make and some clever systems decisions to make in order to allow this all to interoperate. But you can get substantive better cost, better pricing, better control, better performance out of a hybrid solution than you can out of going strict one or strict the other. So rationalization then ultimately does not mean no more cloud. What it really means is evolving into an intelligent hybrid strategy. There are no shortage of projects and vendors to allow you to do this. This is probably the best part, in my opinion. A lot of these are open source. If you want to take the hit and you want to do it yourself, by all means. All these technologies are available. You can deploy them. You can maintain cloud semantics, even in a private cloud environment. So you can go ahead and have API control, and you can programmatically bring things up and bring them down, and you have all the usual scripting that you would expect in order to get your environment exactly the way that you want it. So, to sort of wrap things up, the latest spin of the wheel from where I am sitting, and again, every company is going to be different. Everyone's going to be at a different point on that performance wheel, and they're going to be looking at slightly different, unique circumstances. But all of the, or a large number of the AI companies that I'm talking to are right there in the red one. They've discovered that they really, really, really like AI. They really, really, really want to invest. They're very deeply interested in this. And for all those reasons we talked about, the cost, the control, the data gravity, they really, really, really do not want to be in a public cloud to do it. They want as much control as they can maintain because they want as much security because they are deeply, deeply concerned about other people getting a hold of their data. And yes, I did use an AI to generate the image which says AI. Where do I have proof of that? It's the fact that the data center construction is at record highs. Remember, we started this whole thing just trying to get a feel for where's the industry going, why are we in data centers, and what's happening with data centers, how are we dealing with the hyperscalers, and the problem is that you can see that exponential jump. So this is real, the money is being spent, and it's getting spent here in the US. This is a largely local phenomenon. This is not necessarily an internationalized phenomenon, although multiple parts of the world are trying to go with this. A quick side note, Middle East especially is really interested in new build projects. The US seems to be much more interested in consolidation and rationalization, but once again, this just goes a reminder that everyone is in a different spot on the performance wheel. All right, so we're right to the, towards the end of the talk here in that the ideal case is that you know enough about your workload, you know enough about your use case that you can put together the solution that you want. You build the stack that you want, and you know enough about the industry, and you know enough about everything else that you can pick and choose as to what works best for you. And this is so incredibly important. In my opinion, this is the thing that gets lost the most. Every time you talk to a vendor, yes, they have a point of view, they have something that they want to push. Every time that you have the opportunity to step back and rethink your solution, I think that you will discover the opportunity is there to lower cost, improve performance, improve quality, which is, of course, the overriding thing that everybody wants to do. That's what's driving that performance wheel. So yeah, vendors for every part of the stack if you don't want to do it yourself. And so I want to take just a minute or two, take a question or two, otherwise we'll call it good. Awesome sauce.
Yes.
Yes, sir.
Do you always talk this fast?
Only when it's 5 o'clock in the evening and I'm standing on a stage and want to be sure that I know that I'm being timed. Awesome. Thank you, everyone.